What we're going to do today is look at the sheet metal tools in Autodesk Fusion. We're going to take a look at the best practices. We're going to take a look at the individual tools such as flange, lofted flange, bend, cut, unfold, refold. We'll look at generating flat patterns and working with the drawing side of things. As we get into this, the first thing that we're going to look at is the sheet metal rules and how we generate those sheet metal rules. And I'm even going to throw in a little bit of thing. I didn't put this in our bullet points, but I'm going to throw in the methods for sharing those out. One user creates those, be able to share those with the rest of the team members. So we'll take a look at those. Obviously, we're going to be looking at the flange tools and adding faces and flanges and lofted flanges and so on and so forth. All of that's kind of built into one tool, and we'll take a look at that. And we're going to be getting into the bend tool as well, how we can go ahead and lay out a bend line on a piece of sheet metal and add that in and make some adjustments as we need to. We'll look at the lofted flanges and then adding rips, bends, holes, cuts, the different options that we have for the tools that are built into the sheet metal tab, as well as the unfold and refold tools. We've got some neat little setup with that, and much like some other modelers that are out there, when we need to add features that are based on what would be the flat edge, we're going to be able to do that using these unfold and refold tools. So we'll see that in action as well. And then finally, as far as the model is concerned, we'll look at how to generate the flat patterns, how to pull out a DXF file, and from there we'll move into the drawing side. Just a quick overview of placing those views, being able to place that flat pattern view, as well as adding dimensions and bend notes and some different settings about the view itself, whether we want to see the bend extents, so on and so forth. So really with that's the PowerPoint. So I'm not a huge fan of PowerPoints, and I like to get through them. So with that, we'll go ahead and get into Fusion itself. And I've got it pulled up here. You can see that I've got a little project here with a single file saved in it. And we're going to get into that file here in just a little bit. But for starters, I want to go ahead and run to our sheet metal tab. So I'm just in the design workspace, and we've got a separate sheet metal tab. The first thing that we want to look at is our sheet metal rules. So if I go to the modify panel in sheet metal rules, and I begin to pull that out, I can see this sheet metal library, somewhat similar to a design library or a standard library, but this is still built. This is a cloud library, so we can see some different types here. We can look at the sheet metal. This is the one out of the box sheet metal thickness for steel, and here's a stainless steel, aluminum, and we get into the inch ones. We can come into any one of these. You can see this particular one is set at default. We can come into any one of these and just a simple right click, we can set it as default. We could actually delete the rule if we don't care for that rule. We can even come in and edit the existing rules if we want to. We've got the little pencil on those, so we can edit that rule and begin to make some changes there. Or we can come in, and I'll do it on this one here, stainless steel. We can add a new rule. So when it pops up, we're going to give that guy a name, and let's see here. I think I'll call this one 18 gauge. We can see a thickness here, and I think 18 gauge, if I'm not mistaken, is 05. And we've got our K factor settings. This is what we're going to use for our bends. We can adjust, obviously, that size. There's a lot of different information out there about what K factors would be. but we can make those changes. I'm going to leave mine at 44 for right now. We've got the distance for miters, rips, seam gaps, so on and so forth. We can come back and change this. We can change this on the fly, or we can change it here if we want to. Maybe if we wanted a thinner, we might multiply by, say, half of the thickness. We've got some bend conditions here that we can get in. What is our bend radius? We can again adjust that. What is our relief type? We can see that, and our relief width, as well as our relief depth and the minimum remnant for these bend conditions. And then as we collapse that and get into the corner conditions, we've got two different options in here. The 2D bend, and obviously we can set that relief shape. We've got arc welds, linear welds, however we want to do it. We'll go ahead and set, let's set this one at arc welds. And do we want to change that thickness? We can adjust that as well. And then finally, the 3 bend intersection. How do we want to deal with that? And again, adjust that as we need to with some different options there. So once we have this, we'll go ahead and save this guy. And it is in the library. So the next time, the next file that I open up, sure enough, this will be available in here. I'm going to go ahead and close that just a minute, and I'm actually going to start a shape, and then we'll pick our sheet metal style as we get rolling with this. So I'm going to draw on just our XY plane here. And there's a bunch of different ways you can start these things. You can start with just a simple line and use the flange tool to extend at your material thickness. You can come in and start with a rectangle and draw your first face. Just simply come in, set your values. Let's see, let's do 5 and 8. We'll finish that sketch. And then on the sheet metal tool, under the create panel, you'll notice we've got a couple of different sheet metal specific tools: the flange tool, the bend tool, and we can come in. There's the flat pattern tool down here. These are already up here. They're already there. So I'm going to start with the flange tool, and even though I've got a rectangle here, this flange tool will create that face for me. Notice that it's going to default to that setting in my library. So I'm going to say, no, I want you to go to 18 gauge, and we'll select OK. And sure enough, I've got that one in there. Well, you might think to yourself, what about some other materials, or how do I share this out with other members of the team? And that's what I did here with this sheet metal rules part. So I came in here, created just that rectangle shape, and I created the different types of sheet metal that I wanted. And in this design are these different types. We can switch that, and we'll see this here when we get to the other part in just a minute. We can switch that right here. We can simply select that and pick a new type to add to. Let's just do stainless steel inch. We'll select OK. Now again, if I go back and I look at those sheet metal rules, sure enough, that's in this particular design. Well, once I've got them in a design, I want to get them in a library so I can share this out. And just very simply, we can take these and copy to library. We'll do the next one, copy to library. And the last one here, copy to library. We've already got steel inch in there. And I'll close that. And I can even close this guy. Do I want to save it? It really doesn't matter in that case. That library is a cloud library, so it's automatically populated. We're going to go ahead and just, I'll go ahead and hit my save. Go back to our original, and sure enough, if I come in here, I can now come down and I've got all those different options. They are indeed saved in the library, and we can add those out. So this is a great way, creating that sheet metal rules part where you have all your different possibilities. And the key is that you create them in the library and then activate them in the individual parts so that you can copy them down. That way, someone else opens up that part and all they have to do is copy those from the design into the library itself, and they have all those possible options. You don't have to do that necessarily, but it does beat having to recreate those all the time. Our next little setup here that we'll do is just adding additional flanges, and you can certainly add multiples. I'm just going to pick myself the 4 edges here, and let's see, let's pull those up. We'll set that at about 2. Let's see, I'm dragging too much. There we go. And we can adjust that angle if we want to. I'm going to keep these at 90 degrees. We can see that our gap is based on our sheet metal design here. And maybe we decide, you know, this is a little too thin for what we're doing. So we'll go ahead and let's make that change to, say, 16 gauge. Even on our fly here, we can adjust that. Now, you notice that this particular one, that gap got much bigger. So if I needed to, I can come back and edit some of these things. Either right here in this, if I don't want to change the library option, I can come back and make my alter right here in this design. No big deal. Oop, I did 5 on that one. That's not good. Let's see, times 5. Yeah, not a good thing. Times 0.5. There we go. That's a little cleaner. Let's go ahead and add a few more flanges around this box. 1, 2, 3, and 4. And let's pull those in. It will do that that automatic miter for us. Let's do, say, 0.75. We'll say okay. And maybe we want to cut a couple of keyholes to hang this box. So pretty simple process. We can pick a face back here and just do a simple sketch. Let's see here. Let's do create sketch. There we go. And I like to slice that back. Let's see. 1/4 inch slot. Leave that at 90 degrees. And maybe 1/4 inch wide. And then let's go ahead and add in 1/2 inch circle. Let's make that one just a little bit longer. There we go. That looks a little better. And obviously you can locate this. You can do, you know, however you decide to set that in. Nothing real hard. You can get from the inside edge. You can get from the outside edge, whatever works best. We'll go ahead and add this guy in. And let's go from right here. There we go. Finish that sketch. Now with your extrude tool, the best way that I've found to work with these, you can come and set your profiles here pretty easily. And then I change my distance to all, and I just flip it so that it automatically sets my operation to a cut. I'll select OK on that guy. And let's put in a quick little mid plane here. Say between this side and this side. And then we'll do a mirror of that particular feature. And let's see here. Let's do features. Select that feature, and then our mirror plane. We'll select that guy. There we go. And we've got those in there. Pretty simply, nothing real hard. Now, you know, our modify panel gives us the ability to come in and use the unfold refold. We'll look at rip here in just a little bit. Unfold refold is pretty simple. It works like you think it should. You pick a face. You can select all bends if you want, or unfold all bends if you want to, or you can select the individual bends. And then obviously once you do that, it's very simple to come in and create a sketch, add in a feature, whatever that's going to be, dimension that off your unfolded geometry. Nothing terribly difficult. And I don't know that I actually added a dimension in there. Let's make that 0.75. The biggest thing here, certainly you can go ahead and do your extrusion, get that taken care of. Let's see here, flip that. There we go. And here's your refold. This doesn't show up until you've done an unfold. So once you do the unfold, then you have the refold tool. You can simply select that and it'll fold everything back up. From here, our probably next step would be to go ahead and create the flat pattern. And we can select that guy. We'll pick our stationary face and just simply select OK. And then very easily it lays out our flat pattern. We'll come back to this guy here in just a little bit. Let's save this one and just call this JBox. We'll save that one. And let's start something new here. So once again, and you can start your sketches if you want to outside of the sheet metal environment. They don't have to be created inside of that sheet metal environment at all. So let's see here. Grab us another rectangle. And let's do 6 by 6 on that one. And then let's go ahead and create an offset plane. We'll drag this guy up, let's say 0.4. And we'll create a sketch on this. Finish that sketch. We'll run back to the sheet metal environment with this one, and we'll use that same flange tool. And notice that we've got the lofted flange option as we go here. I'll select this guy and select this guy. Notice it automatically goes to our, and I guess this was the last one that I used, the 16 gauge. So it will go to that. We have the options to select one of the others if we want to. I'll simply select OK here. And let's use that rip tool. So I can select rip. The best way that I've found this is to come in and, if I want to rip right down the middle here, select that middle point down here first, and then come up and select the top. That gives us a nice setup here. We can then come in and adjust that gap width if we want to. We can make changes to that if we need to. Not too much trouble. From here, it's simple enough again to get our flat pattern. It's going to ask us for a flat edge. I'll take this face back here, and there we have our flat pattern for this guy. You can do. I'm going to do one more little setup here. You can do bends if you want to draw out your flat pattern and you want to create your own bends. You certainly can do that. One of the nice things is that as you lay this out, let's see. We'll go ahead and get our face in here. And one more sketch right on this face. Let's see here. I'll just put a line right about here. So if you want to locate that line, and notice it's just there. It's not, I haven't set any kind of specific distance on it. I'll offset it. And let's set that at 1 inch. We'll finish that sketch. And we do have that bend tool, so we can select the bend tool, select our stationary face, and select our bend option. And again, set the degrees. Do we want a corner relief? Do we want to override the rules? Maybe we want to change the bend radius. Whatever we need to do, we can adjust those things. So pretty simply, it does not consume that sketch. So you would have to come in and go ahead and turn your sketch off. There are, you know, if you look at the sheet metal tools themselves, you've got flange, bend, and flat pattern on the create tab. You've got unfold, sheet metal rules, and rip on the modify panel. That's it. There's not a lot there. Most of the stuff that we need to do, we can do right here with these tools. There are some things that hopefully will be coming along, some more of the higher order tools, if you will, things like contour flange. You certainly can create contour flanges just by creating the sketch itself. Contour rolls are yet to come. We'll see those in the future, hopefully. These really are the tools to create your sheet metal parts. Coming back to our original J box here, I did want to point out here's your export. So you can export that as a DXF. Take that over to burn tables or whatever. You have that option, and I want to use this one as well for the drawing side. So I'm going to come in here and we're going to go from design. We're going to select the drawing workspace. We'll choose from design. When we do that, obviously we've got to set our paper size and you know, are we creating a new one? Are we adding into one? How are we setting that up? Let's see here. There we go. Template from scratch, or if there's one that we've got, we can add that in as well. And I'm simply going to select OK. Give this a minute to pull up our template. And we have our first setup. Now, in this particular case, it's pulling from that flat pattern option. I'm going to cancel this just a minute, and let's go ahead and close this guy. Let's step back in and finish out our flat pattern. We'll get back to this this spot right here. I like to go ahead and do a save. You don't absolutely have to, but I like to go ahead and do a save. Let's do that. Let's do that drawing again. We'll come in from design. We've got everything set. We'll select OK. And here we have our option. So we can do something like an isometric if we want to. That's not a big deal. Obviously, set our scale here. Let's set that 1.5. There we go. And I can go ahead and place this view. Let's see here. And we'll select OK. Now I can come in and do some things like, hey, wait a minute, let's go ahead and make this shaded. Let's go ahead and set our tangent edges and so on and so forth. We can turn these on if we want to. I'll bring in our next view. Let's see here. Let's go ahead and create a base view. And there we have our representation. Do we want the folded model or do we want the flat pattern? So let's bring in the flat pattern. Let's set this, say, at 1 to 2. See if that'll work for us. Yeah, that works just fine. From here, again, you've got some options in here. It shows by default the bend extents. If you don't want to see those, certainly you can edit this view and you can turn off your bend extents right here. Easy enough. And then your annotation options, if you want to add a bend note, that's under the text size. So we can select that and add our bend notes in however we want to do that. And then obviously setting in our dimensions, any center lines, center marks, whatever we would want to do. Sheet metal in Fusion is pretty easy. It really is. Certainly, if you're in a design such as our J-box here and say you want to create the cover, then it's not that hard to go ahead and create a new component. Again, work with your sheet metal tools, or maybe it's not a sheet metal part that goes on here. However you want to do that. So pretty simple process. I encourage you to use the tools, work through those tools. That is what I have at this point for the demonstration. Let's see here. Any questions? Let me pull up this questions panel. Let's see. I don't see any questions that have come across thus far. All right, does anybody have any questions at this point? It's seeming like we don't. There's quite a few. It's a pretty simple process. Want to point out that we do have training offerings for Autodesk Fusion. In our training class, in our typical training class, we cover getting started with Fusion, starting from very scratch. And then most of the components are the standard design components. We don't get too much into the sheet metal side, but certainly if that's a need, we can go in and look at those options. I do see that Moan Rayo has a question here. Let's see here. What is your question, sir? You can go ahead and type that into the question panel, Moan. Can you import 2D drawing from AutoCAD into Fusion? It is possible to do that. That is a little bit different. Let's see here. If you go in, you can open or start. You can open a DWG file, if I'm not mistaken, open from my computer. And DWG is indeed one of those, so you can open that up. That should convert those. If not, give us a holler. We can take a look at what you're getting into. The copy and paste, like we do with Inventor, is a little bit more challenging with Fusion. It doesn't work that way. So there are ways to bring in your 2D objects. Yes. That was from Brenda. Juan, do you still have a question? No? Ah, there we go. That is a very interesting question. There is not a way to lock those down in the sense that they can go in and individually edit their library access. if they do that, and I apologize, I should have read the question for everybody. Able to edit the cloud rules easily. Is there a way to prevent users from messing up the sheet metal rules? Basically, what you would want to do if a user goes in and changes the library rule here instead of in the design itself, you would simply just delete that, go back to your defined template, if you will, or your sheet metal rules template. Open that and then add that back into the library. It's probably something that if you use, or if you happen to use the manage tools inside of Fusion, you can set that in a release state, and that would lock that file so they don't change that particular file. These changes that would be here would be for this user, for my access to a cloud. So each user, if you will, has their own cloud library. That's why you have to do the things like create a part that has it all and then share that part with everyone so they can copy it to their library. I hope that answers your question. Any other questions? Okay. Let's see. As I mentioned, we do have the Fusion new user class. Certainly enjoy teaching that class. That's gone very well for us so far. And Michael asks what types of files can be imported or exported from Fusion. That's a very good question, Michael. There are a number of different file types that can be brought in. Let's go back in here just a minute. Let's see. So once again, doing the file and open, you can't start a new design, but you're starting a new Fusion design. So then browse from my computer, and let's see here. A little challenging. It flies off the screen. I'm going to see if I can slide this over and maybe make it pop this side. Nope, I'll slide it way over here. So as you go in and you look at your different options, there you go. You can see all the different file types that are able to be brought into Fusion and used in some sort of way. Some of these files, things like the STL files, where it's a mesh type file, the T-splines, those require some extra steps to be able to edit those types of files, but they can certainly be brought in, placed in assemblies, if you will, as components. Obviously, you've got DXF, FBX, the standard type files, Pro-E, SolidWorks. All of these are available. Certainly, your AutoCAD files, your Inventor files, these can come in. Now, when it comes to the drawing sides themselves, such as an AutoCAD drawing, title block, border, all that good stuff, that's a little different setup. You're really wanting to pull information from the model tab as opposed to a view tab where you've got your title blocks and whatnot. And some of these others, you notice that there's not a DWG or an IDW setup from Inventor. There's not CATIA drawing files or SolidWorks drawing files. These are the types of files. These are model files that you're going to be bringing into Fusion. And then obviously you have the drawing environment where you can create drawings for those. Any other questions? I might be flipping back to my slideshow a little too fast. All right. As far as saving out, Michael asked what can be exported. You do have an export option. Let's see here. Let's go to this one and export. And again, your 3MF files, Inventor 2021 files. When you export a solid file or a model file from Fusion into another product, it's going to become what we refer to as the dumb file, where you'll see all the geometry. It's just not going to have the feature history. You can see some options here: STL files and step files, and let's see, IGES files, OBJ files, FBX. All of these can be brought out. Obviously, you can take a SAT step, IGES, send it to CATIA, ProE. Any one of those will be able to open those up. Certainly, you've got your STL and OBJ files for printing with the 3D printers if you need to. You can send those file types out. So all of those are there. Okay. Let's go back into that last little bit of the slide. You guys have all seen this before. We offer a variety of skills and assistance with document management systems and some of our own tools that just make life a little bit easier, the QVP and Lifecycle, as well as backup connection and project connection. We certainly have those options. We've been through some of those questions. Anybody else have any questions before we call it a day? All right, I think that's it.